Okay, so today we are working on NS14, dividing integers. And first off, let's just begin at the beginning. Opposite sign. What does it look like? Positive sign. What does it look like? So opposites means negative. Same means plus. Okay, moving on. Next, rules for dividing integers. So when we're dividing integers, it's similar to when we're multiplying integers. What we want to do is when dividing integers, if the dividend and the divisor are opposite signs, the quotient is negative. So we're going to put negative here. But I want you to understand what that means. When dividing, you know that is the opposite of multiplying. The dividend and the divisor. So what that is the difference of when we have a product, we multiply. When we have a quotient, that word means to divide. And the dividend and the divisor are, if you look down here, you see these numbers are the dividend and the divisor. That's what those places are called. Like, that's what the number in that spot is called in the equation. Now, when dividing integers, if the dividend and the divisor are the same sign, the quotient is positive. So just like when we're talking about multiplying, if we multiply or divide, either one, we're multiplying and dividing, the quotient, the answer here. Okay, when we're multiplying and dividing, our quotient for dividing is the same as our product for multiplying. A negative and a negative is a positive. A positive and a positive equals a positive. And a negative and a positive in any order gives us a negative. So we put our divisor here. Sorry, I'm trying to write really small, and I know it's hard to see. Can you guys see that? D-I-V-I-S-O-R. All right, and then inside, that's the divisor, goes the dividend. Dividend. Okay, so that's where they go in a traditional algorithm for dividing. They go inside this little bracket piece here. This is a division symbol. All right. Now, a dividend divided by the divisor equals the quotient, or answer is what this is also called. Okay, so this is also called the answer. Alright, and this is the problem. This is your first number divided by the second number. Now, over here, we have opposite sign example. So, opposite signs. This one's a negative, this one's a positive. We don't have to put the symbol in there, but we know that that 3 by itself is a positive. So, 9 divided by 3 is 3. Negative and a positive is a negative. Okay, just like we said. If this is negative and this one is positive, this one is negative. If this one is negative and this one is negative, then this one is positive. If this one is positive and this one is negative, then this one is negative. If here we have a positive and a positive, then we get positive. Okay? Those are our 4 possible combinations. Now, let's try that again. So, a positive 25 divided by a negative 5. So, 25 divided by 5. So, 25 divided by 5 is 5. And then we have a positive and a negative, which we know if this one's positive and this one's negative, we get negative. Now, same sign. That's that negative and a negative is a positive, and positive and a positive equals a positive. So, a negative 9 divided by a negative 3, it's still 9 divided by 3 and gives me 3, but that negative and negative makes this one positive. 20 divided by 4, 20 divided by 4 is 5, and it's a positive divided by a positive, so we have a positive. Remember, if the dividend is 0, the quotient is always, obviously, 0. And 0 is not positive, nor is it negative. So 0 divided by 3 is 0. And 0 divided by 7 is still 0. We can't multiply, nor can we divide with a 0 without the answer being 0. Because remember, this is 0 groups. Excuse me. This is 0 groups of 3 is still 0. Because we read it backwards for dividing. And 0 groups of 7 is still 0. Alright, next part. Let's look at the 12 divided by negative 3. What does that really look like? Well, I have 12 positives divided by 3. So we break it up into 3 groups. 1, 2, and 3. So I still have my 3 groups of what? Well, in this case, I have 3 groups of 4. But since it says the opposite, I bring that over here also. I have 3 groups of 4, but there are 3 groups of negative 4s. So when we go and say, how do I get back the other direction? 3 groups of negative 4 is do the opposite of 3 groups of negative 4. That would be negative 12, and the opposite would be a positive 12. And so there's that 12. Trying again. If we have 10, we know our total is 10 negatives. We have 2 groups. So we make 2 groups here. And we know that something had to be negative to make this into a negative. And it gives us 2 groups of 5. So we have 2 groups of a negative 5. And that gives us a negative 10. So dividing is literally doing multiplication in reverse. So let's look at this one. What does this represent? And what we're looking at, how does it represent what we're trying to say? Well, that's pretty easy. So the first thing we want to look at is, well, we have 12 total, right? So we have 12 total. They're all negative. So we have 12 negatives. We've split them obviously into 3 groups here. So we're going to be dividing by 3. And what does that give us as an answer? Well, that gives us that we have 4 in a group. And if we look, we have 4 negatives in each group. So we have 3 groups of -4 to give us -12. We come over here and we see not a -12. -12 divided by 3 is a +4. No. -12, 3, there we go. So this one gives us the +3 and the -4. So it should be C. Next one. Looking at Tyrone owes $32 on a layaway item at a music store. He repays his debt in 4 weeks. Which integer correctly shows how much Tyrone paid weekly if he paid the same amount each week? Okay, so Tyrone has $32. So we know that he's got $32. So let's put that down. On a layaway item at the music store. Okay. He repays his debt in 4 weeks. So we know that over the process of 4 weeks, he's going to pay this amount. Which integer correctly shows how much Tyrone paid weekly if he paid the same amount each week? Okay. Let's see. So if he's paying the same amount each week, he would have to pay 32 divided by 4, and that gives us $8 each week that he paid in. Now, let's see. Which expression below equals a -7? Okay, so let's solve them. Go for the easy one first. 4 times 2 is 8. 28 divided by 3. Let's see, that's, I don't know about you guys, but that doesn't come out quite right in my head. That's going to be 9. We're going to have 1 left over, so a third. So 9 1/3. That's not it. Then, let's see, 20 minus 3, but it's a -3. So 20, do the opposite of subtract 3. So the opposite of subtracting 3 is to add 3. That gives me 23, so no, that's not it. And 21 divided by 7, or by 3 is 7. And it's a negative, so I need a -7. Alright, that would be it. Which expression below equals 10? Well, let's work them out. 3 times 2 is 6. We have the negative. 20 divided by 4 is 5. 5 plus a -5 is 5 minus 5, and that equals 0. And 2 times 5 is 10. Alright, so that should cover us on all of these. Any questions you have, please let us know. And again, the easiest way to remember some of this stuff, and you don't have to write this down, but when we add and subtract, we use same signs equal the same sign. So plus equals plus, and negatives are negatives, right? So a positive plus a positive equals a positive. A negative plus a negative equals a negative. And then when we do that negative plus a positive, it's the bigger sign, so the larger sign. And when we subtract, we do positive minus a positive is going to be wherever it lands. So this converts to a positive plus a negative. And then we just go up here. Negatives and positives, it's whichever one's larger. If we have a negative minus a negative, again, it changes to a negative plus a positive. So do the opposite of a negative, which is add a positive. And then if we have something, for instance, negative minus a positive, then we can say this is a negative plus a negative. And we have a positive minus a negative. It becomes a positive plus a positive, because we do the opposite of a negative. Okay, now look at that next to our multiplying and dividing. Because when we multiply or divide, same signs equal same. So positive times positive equals positive. Right? So when we're the same here, we get positive. But in this case, we're not getting the same signs are the same. We're getting the same signs are positive. Because when we say a negative times a negative, it's a positive again. So you see how that happens? So you got to watch. Are you adding and subtracting or multiplying and dividing? When we say a negative times a positive, we get a negative. Doesn't matter what order. A positive times a negative is a negative, and a negative times a positive is a negative. Doesn't matter which order they're in. It's still a negative. When we divide, it is exactly the same thing. We divide. Same signs, equal positive. Different signs, equal negative. So compare those two. Look at the differences. So we're same signs gives us the same thing here. And then different signs, we have to work it out, make adjustments, changes. You know, we either use the larger sign. If we're subtracting, we convert it to an adding so that we can find that sign. When we're talking about multiplying and dividing, it's the opposite. We say same signs are always positive and different signs are always negative. So look at those two comparisons and work on that. Those are the two big things to remember, because these rules for each of these are different. These rules and these rules are not the same rules. So when you're multiplying and dividing, make sure you're not trying to do the same rule as adding and subtracting, because they are different. All right, guys, get started on your math practice, and we'll catch you later.